Okay. Hide. Okay, nice. Can everyone see my graphing calculator?
Yeah.
Yeah. Good. Okay. So this unit is absolute values. And so this little subunit is called modular modular transformations. And the idea is that we're going to be taking regular functions and putting them like in absolute values. So let's talk about absolute value first. So the idea is you turn your calculator on and you have a graph. You create the graph. What we're going to do is tab. The button next to the 9 is absolute value. And then we're going to put an X inside of there, hit enter. And that is what the absolute value function looks like. You kind of notice it's kind of like a piecewise function. When X is greater than 0, it looks like the line Y equals X. But when X is less than 0, we notice that it's like the line Y equals X. Now, we can make transformations to this. For example, so let's go to tab. And I'm going to, negative 2, I'm going to times, and then I'm actually going to use the function f1. Let's see, f1, open parentheses. I'm not answering a question, or you just ask a question out loud.
I missed where to get the absolute value on the calculator.
Right here next to the 9.
Okay, thank you.
And then I'm going to do, let's see, 3 times x minus 1. And then let's move outside. And then we're going to do, oh, I'm sorry, we're taking this out. How about plus 5? And then let's turn this on. Let's see what happens. Let's hit enter. Sorry. Nice. So what happened? What did we do to our original absolute value? Well, we can see I moved it 1 to the right, and then I did a horizontal stretch with a factor of 1/3. Then I did a vertical stretch, a factor of 2. Then I reflected it through the x-axis, and then I moved it up 5. So this is a basic transformation. It's no different than any other transformation. Nice. And you'll see once you're doing the exercise, you're practicing. Next. The next thing we want to talk about is solving absolute value equations, which I believe you did in Algebra 2, but we're going to do it on the graphing calculator. Now, the first problem I encountered was I tried to do this. So once again, I tried to do this on the calculator part. And you can see that I use nsolve. So what I did was I went to Menu, Algebra, Numerical Solve, and I plugged the equation in. I did right next to the 9, absolute value of x, let's see, x minus 3, move the cursor outside the absolute value, equals to 9. You have to do comma the variable. So if you make it like K for Ken, or A for Amani, or S for Siri, you have to make sure these are the same letters. Or J for Josh, or F for Farzad, or F for Faria, or J for Jake. Anyway, you hit enter. Now the problem is we know that there's 2 solutions, but my graphing calculator only gives me 1 solution. I'd like to know if anyone, I think there's an nsolve. Does anyone's calculator give them the 2 solutions? If not, we have to figure out another method. So what I decided was I'm going to graph the left side and the right side of the equation. So go to Menu, not Menu, I apologize, Escape. Go back to the graph, and let's take these graphs out. Tab, arrow up, Control, Delete, Enter. Now let's go down to 2. tab, go down to 2, Control Delete, Enter. I want them all out. Next, I know the left side of my equation was absolute value of x minus, what was it, 3 or 2? Let's just say in the presentation it's going to be x minus 2. So I'm going to do tab, absolute value of x minus 2, enter. Next tab, I'm going to make the right side of the equation 9, hit enter. Well, I need to expand my window. I need to make this bigger. So, and I know there's probably going to be some like intersection out west and the right. So let's go to menu, window. I'm going to do my own settings. So my x min, let's leave it -10, but my x max, I'm going to expand it to 15. My y minute, well, that's 0 because I'm only dealing with absolute values which are above. But my y max, let's make that. We know that we put the line y equals 9, so let's make this like 15 also. Okay, nice. The question is, what are these two intersection points? Well, let's find the intersection. We know the y values are going to be 9. What are these x values? Once again, so menu, analyze graph, intersection, move it a little bit. So let's start with the intersection on the left. Start with the left, move it a little bit to the left, hit enter. Move your cursor a little bit to the right, hit enter. The first intersection, x equals -7. Now let's find the second intersection. Menu, analyze graph, intersection. Let's move it a little bit to the left of the second intersection, enter. Now move it a little bit to the right, enter. My second intersection is x equals 11. And so the two solutions are x equals -7, x equals 11. Remember, I think I changed it. I think before I did x minus 3. This is x minus 2. The next thing we're interested in is solving absolute inequalities. Now, what you can do, so let me take this out. Let me show you the graphing calculator a little bit better. Another thing you can do is use the graph to find the solutions, but we're not going to do that. So let's try, the next equation is going to be absolute value of 2x plus 1 is less than 5. Okay, let's go to tab. Let's go up to F1 and let's change this. You can either delete this or redo it. I'm going to delete the whole thing. Once again, the absolute value, I said it was 2x plus 1. Absolute value of 2x. I think actually, you have to do times. 2 times x plus 1. Hit enter. And we're going to change that second tab to, we're going to change to 5. Enter. The question is, when is the blue less than the red? And you can physically see between these 2 points. So find the 2 intersection points. And then, so once again, let's find the intersection points. And we can determine when the blue is less than the red. When 2x plus 1 is less than 5. Go to menu, analyze graph, intersection. Let's start with the intersection on the left. Lower bound, enter. Move the cursor to the right. Enter. The first x value is -3. Now let's find this other intersection point. Menu, analyze graph, intersection. Move it a little bit to the left. Enter. Move it to a little bit to the right. Nice. So the equation, the absolute value of 2x plus 1 is less than 5. The answer is all values between -3 and 2. Once again, I'm going to do this on the board. And then if you want to find greater than, you'd know that if I said when is the blue greater than the red, you would say, oh, when x is less than or equal to 3, or less than -3, or when x is greater than 2. Okay. And then the last thing might show up is they ask you to find, sorry about that, they might say, sorry, escape, tab. One instance, they ask you to do 2 absolute values. So let's delete this. Let's put another one in. Absolute value of, you need to like 3x, 3 times x plus 4, enter. So we see that the absolute value intersect, these 2 graphs intersect each other. These 2 graphs intersect each other, and you might be asked, when is one above the other? I encourage you to solve it graphically. And the way I describe it is I say that the right branch of either of these is 2x plus 1 or 3x plus 4, but the left branch is negative 2x plus 1 and negative 3x plus 4 because we reflected the negative part over the x-axis. So that might be that's the way I'm going to talk about it algebraically in the video. The last thing we want to talk about is the effect of taking these functions and putting them in absolute values. So let's go back to tab. I'm going to go up. I'm going to delete this out. Enter. And I'm going to tab, go back to the top, and I'm going to control delete this out also. So enter. Okay. So the question is, what happens when menu, window zoom. I'm going to put it back to standard. Nice. Okay. The question is, what happens to functions when I stick them in the absolute value? Very easy. Tab, first example, 2 times x plus 3, enter. So I have this function, and the next thing I'm going to do is I'm going to tab, in F2, I'm going to take the absolute value. Let's see, so absolute value of, if I can just click that. No, let's see, f of 1. F1, open parentheses, x, enter. Nice. I think we discussed this before, but let's see what happened. The blue had it was a regular line. What the absolute value does is take the negative part and reflects it over the x-axis. And let's try this again. Nice. Let's try another function. So let me go to tab. Let me go up to F2. Let me hide it because I don't want to spoil the surprise. Let's go back up to F1 and let's change that. Let's take that out. Let's put a quadratic in. How about x squared? So let's see, x to the second power. Let's see, plus 3x minus 10. And hit enter. Let's see. Okay, you know what I'm going to do? I'm going to zoom out. Menu, window, zoom. Let's zoom out a little bit. And let's go down there. Let's see if I can get this. Nice. Okay. So, well, you know what? Some of you might be saying, hey, Mr. Adler, if we're reflecting over the x-axis, maybe I need to be a little higher up here. So you know what? Let's go to menu, window, zoom. Let's personalize the window settings. So you know what? The min is negative 21. Sorry, I'm talking too much. Let's make that max 25. Oh, no, I'm sorry. Let's see. It was 18. Let's see. It was 19. The Y max, once again, we want big. Let's go 25. Okay. Sorry. Next. Tab. Let's put this in. Let's see what happens. Nice. Sorry. Talking too much. What we saw is that the negative part got reflected over the x-axis. Any questions? Any questions? Are you there? Can you hear me?
Yeah.
Okay,
Yeah.
hold on. I'm going to run down the hall and get water. I'll be right back. That's my mask on. You know what? No. I'm good. I can survive.
Water.
I'll figure it out. I'll get through this. The next thing we
You
want to
can do
do. Sorry. So once again,
I'm just encouraging you. Sorry.
So you get a video. Okay, I'm getting water. I'll be right back. Wait, where's my mask? I can't leave the room without a mask on. Hold on 1 second. Sorry.
Now I'm honestly thirsty. Hi, are you ready for the test? No. Are you? I'm trying to pull up statistics on every topic we've covered. Yeah, me too. It's so hard. I know. What subject? French. French.
Okay, I'm back.
Enjoy. Vegetarianism, crudivorism, diets, eating disorders, perfect body, junk food, meditation, and mindfulness.
Oh. Okay. So that's one thing IB wants you to know. The next thing IB wants you to know is, let me take this out. What happens if, let me take this out. We take our original function, f1, open parentheses, but replace every x value with absolute value of x. That's what they want to know. Let me take this out. Enter. So what happens to the original function? So I'm going to go back to this. I'm going to take it out because there's a better function to look at. So the original function, let's see, enter. We're going to, whoops. Yeah, nice. Do I still have my F2 in there? Yes. So the function we're going to be looking at is x times, open parentheses, x minus 2. And you say, oh, that's easy to graph, Mr. Adler, because I know the zeros. There's 0 and 2, and it's a smile, and the y-intercept is 0. This looks nice. Let's see what happens. So first of all, menu, zoom. I'm going to put my back to standard because I want to get in there. Now, let's see what happens when I take those x values and replace them with absolute values of x. Let's see, up there, ready? Is everyone ready for the excitement?
Yeah.
What happened? What happened when we replaced the x with absolute value of x? Well, we see, oh, I got a recognition certificate. Can you see that? You want to see them afterwards? Anyway, what you notice is that it seemed like the left side of the graph, the graph from x was greater than 0. It went along its merry way, and then all of a sudden it was like it was reflected. It was reflected over the y-axis. And if you think about that, if you think about it, all the negative values take on the output of the positive values. So, like negative 2 is the same thing as 2. Negative 3 is the same thing as 3. So what I'm going to show you in the video is graph your original graph, erase everything to the left of the y-axis, and then reflect the graph through the y-axis, and you get this is the transformation when you replace x with absolute value of x. And this works with any function. We can let's see, tab. Let's go back up. Let's change it to you can do a cubic, right? Let's hit enter, tab, up to F1, good. How about like x to the third? Enter. Perfect. So we know what x to the third looks like, but then the idea is that when we replace x with absolute value of x, that negative part gets erased, and it's now a reflection through the line. It's a reflection of the positive part over the y-axis. And that's the GDC aspect of it. So now I'm going to shut this video off. I think we're done. Let's see, stop